Welcome, student council members. Welcome. Remember, everybody, this is where we were. And remember, we learned a shortcut. And the shortcut was, if it's not in quadrant 1, that the two angles beta and theta add up to 450. So we said real fast, if bearing was 310, that the direction or theta would be 140, right? Theta equals, because these two have to add up to 450. That's the magic number. So if you don't remember that on a quiz, you're going to have to do it like the left slide over here. So if you don't remember that, you're just going to have to do it longhand. Okay? So the next couple slides deal with that first really confusing vector resolution equation that you wrote, okay? And all it says is this. When you see a problem, you know, either I write it out or it's in the book. If the problem has bearing listed, you have to answer the question in bearing. If the problem listed has theta, then you have to answer the question in theta, okay? So if it starts in beta, you got to finish it in beta. If it starts in theta, you have to end it in theta. This is the difficult one. This one's easy. And by difficult, I mean you have to subtract from 450. So if it's in theta, you just leave it. Got it? So if it starts in beta, you have to end it in beta. If it starts in theta, you have to end it in theta. Easy enough to remember? Okay, so all the problems that we did from the last section said a boat sails north 50 miles and then goes on a bearing of 30 miles. Or it, like every problem started with either a north, a south, an east, or a west. Okay, today's don't have to. So today's can just start any bearing or any direction they want. It's all good. Trust me, if you have a calculator that you know how to operate, you're going to be fine. Can we move on? Okay, here we go. So you've already written this down. You already wrote this down. That's the puppy that I'm going to be dealing with on the next couple slides. But the thing that you need to know is that that yellow equation only works in theta. So if it starts in bearing, you got to convert it first. That's the only thing that you have to remember. That equation only works in direction, not bearing. It only works in direction, not bearing. Okay? All right, let's try some. Oh, never mind that slide. Don't worry about that. Okay, let's try one. Here we go. This isn't difficult. It's just new. Don't freak out. It's nothing crazy. All right, so here's a big word problem. I wish that I could have printed off slides for you, but I didn't this morning because I was photocopying multiplication charts for algebra class. No, don't worry about that. I'm going to show that to you. I don't know why that smiley face is there. Makes me wonder if I should click on it. Sometimes I attach a sound to an image, but I didn't there. Oh well. Okay, so a car travels 60 miles with a direction of 40 degrees and then 70 more miles at a direction of 120. Find its resultant vector and direction from start to stop. If I try to draw this freehand, it would be kind of a mess. I'm not going to. I'm going to go straight to calculator. Okay? Let me even get rid of this slide. Okay, so I'm going to go straight to the yellow equation. Are you ready? It's not difficult. Okay, it's in direction, which means it's theta. So this is theta, and it's in direction, so that means this is theta. All right, so 60 goes with 40. 60 goes with 40. You ready? So it's 60 cosine 40 I plus 60 sine 40 j. And those are actually vectors, I and j, so I know that some science teachers would freak out if I didn't put the little arrows above it. Now, that was just for the first distance that it traveled, right? Now, I have to go in green 70 more, direction 120. So 70 goes with 120. 70 cosine 120 I and 70 sine 120 j. Add down. In other words, this yellow blob all goes together with the plus sign between, obviously, the top one and the bottom one. And then this blue blob all goes together with the plus sign between it. So that's why I said add down. You add the i's and you add the j's. Here I go with my calculator. So in my calculator, I'm just punching 60 cosine 40. I hit equals. I get a decimal, big deal, plus 70 cosine 120. I hit equals and I get 10.96 I. See if you got that. Did you get 10.96? Rounding to the 100th sounds perfect today. Now I'm going to do the blue blob. So 60 sine 40 hit equals plus 70 sine 120 hit equals, and I got 99.19 j. Yeah, I sure did. Isn't the mind funny? I said 9, had no idea that I wrote a 2. Did you all get that? Straight out calculator. Okay, now normally I would, hopefully I have a blank slide. Yes, okay. So now I'm going to do a drawing. So I'm going to do a drawing because instead of doing like really tough stuff and trying to, you know, like, oh, what direction do I have to go? North, south, east, west? Now I can just draw a right triangle. Here we go. This is X, 10.96. This is Y, 99.19. Let me move the 10.96 this way. This is my bow tie angle. Somebody even said bow tie angle yesterday. Somebody even said bow tie angle. And there's a right triangle. You guys are always going to be able to draw a right triangle with those two vector resolutions. So you have an I component and a J component. I is X, J is Y. I don't know why it is. It just is. And then the resultant vector is right here. Resultant vector. I'm going to use the Pythagorean theorem.
How did you know which way to go, though?
Since the 10 was positive, I went to the right.
Oh.
And then since the 99 was positive, I went up. Okay, so now I'm going to use the Pythagorean theorem. Always. and I'm going to get R. I think it's going to be real close to like 100. Let's find out. It just seems like it should be, doesn't it? Uh, 99.79 is the resultant vector. Okay, that is miles. And now to find the black dot. The black dot is the from start to stop. Okay, so the black dot angle is start to stop, and the smart one to use would be tangent, right? So tangent theta, or whatever you want to call it, is going to be 99.19 divided by 10.96. And so I'm just going to do shift tangent and get 83 degrees, 83.7 degrees. Okay, so the resultant vector has a magnitude of 99.79 miles, a direction of 83.7 degrees. Don't use fraction bar. Try divide. Okay, so this is the direction. The book might use the word magnitude. So this is the magnitude. Magnitude and direction of that resultant vector. R is positive, right? It's the hypotenuse, just like before. It's going to be positive. Ta-da! Let's do one more, and then that should be enough. Then we have bookwork 3, 2. So is that easier? I think so. Pythagorean theorem and tangent. Big deal. By the way, we could have done last section's problems this way. If you like this way better, it works. Okay, let's try one more. Bum, bum, bum. A ship goes 25 miles, bearing 330 degrees, then turns and goes 8 more miles, bearing 260 degrees. Find the direct line distance from bearing from start to stop. Got it. Can do. It's easy. I hope. Should be, right? We can do it. Write it down first. We only need to do 2 examples. Remember when I said bearing problems are harder? This is a bearing problem. I don't want to make the video too long because it takes forever to upload. Forever.
You should have like paused it.
Oh, it's okay. Okay, on these problems, bearing is bad. So I have to play the 450 game. Unless one of those bearings was between 0 and 90, I have to play the 450 game. So I'm going to mark off this bearing of 330, and I'm going to write theta equals 120. You get that? That's the 450 game. I'm going to mark off this bearing of 260, and I'm going to write theta equals 190. Had to think about that one. Okay. Everything else is the same until the very end. So I'm going to go kind of fast on this one, just so that you guys, start getting the hang of it. All right, so it's 25 cosine 120 I and 8. Oh, sorry. I'm following this guy right here. So 25 sine 120J. And then underneath in green, is that what color I did the other one in? Ah, dang it. I used the wrong color. I'm sorry. Then it's 8. It's just grouping. Then 8 goes with 190, right? 8 cosine 190I, 8 sine 190J. Draw a line, add down. Maybe this one will be more interesting, like a negative number or something. I hope. Is it? I'm hoping that. I'm hoping. I was just hoping. All right, so I got a negative number, negative 20.38I. That just means left, okay? That just means left. And now I got to do the other one, 25 sine 120 and 8 sine 190. Oh, did you get a positive for this one? 20.26 J. Okay. It means left and up. This means left, and this means up. Hopefully I have a blank slide over here. Yes. So here's my drawing. I'm going to go left this way, and then I'm going to go up that way. And then we're going to discover, should I keep the negative here or not? Let's find out together, shall we? Let's find out. Can I have a negative 20 for the length of a side of a triangle? No, but we're going to need to keep it there when we're trying to figure out maybe that's going to affect my tangent. Okay, so we're just going to kind of keep it there. Just keep in mind that it just means it's going 20 left. Okay, here goes Pythagorean theorem.
So when we're doing that, you said we keep the negative?
I'm going to keep it there for right now. But when you square anything negative, it turns positive, right? Okay, so here's what I got for the resultant vector of the, this is R right here. I got 28.74. Hopefully somebody else did too, just to confirm it. 0.74-ish. Okay, now I'm going to put this dot right here. I can call it theta or whatever. Let's see if I need to keep the negative or not. Ready? Let's try it. So this would be tangent theta is of apples. Let's see what happens if I use the negative. Shift. I'm always going to be finding the bow tie angle. Good question. Yes. Oh, shucks. What happened to my answer? Can I have an angle that's negative 44.8 degrees? Now, let's just see, just for the heck of it, what happens if I just keep it positive, okay? Let's just see what my calculator does. I got to press in the button correctly. Oh, did you get a positive answer though? Okay, so what do you think this angle is right here, just ignoring the negative sign? What do you think this angle is? 44 point whatever.
So it doesn't not matter.
You just need to remember that an angle is going to be positive. Okay. So 44.8. Is that the final answer?
No, you're estimating its bearing.
If a problem starts in bearing, it's got to finish in bearing. So I have to find the bearing, which is here, here, here.
So 270 plus 34.
So bearing's going to be 270, which is 90 plus 90 plus 90, right? Here's a 90, here's a 90, here's a 90, plus 44.8, ignoring that negative sign, right? So 270 plus 44.8 is not a fraction, the bearing of 314.8 degrees. They're not scary. It's just different. Okay. All right, so I want you to try a couple book problems. Maybe. Really? I didn't write it down? That's a lie because I have it memorized. It's just that sometimes I like to look at my book to make sure that my memorization skills are correct. Yeah, okay. So try number, I want 1 theta and 1 252. So bearing, bearing, bearing. That's cool. So we're going to do 6 and 8. Okay, the first one isn't a word problem, big deal. The second one is, and it's in bearing.
You just like write it up there. What does it mean by like as it sounds to?
That's, you remember how I said you got to add down? That's the add down part.
So basically, A and B is just like all the steps you did.
Yeah, that's all I want you to do. You want to see what 6 looks like? 6 is, number 6 is 12 theta 160 and 8 theta 310. Okay. And then number 8 is 30 bearing 200. And then 40 bearing 10.
So it's in the first one though. So does that mean
The first one's all good.
no number 8? Like it's 30. So we don't have to subtract, or we do still have to subtract.
No. Don't. The 30 is the distance, so like 30 miles. The bearing is 200 degrees, so you got to convert the 200.
Oh, okay.
You got to convert the degrees. Yeah. So the red one, you got to convert the 200 and the 10.
I wrote them like opposite.
And stopping the video. There you go, Stuco people.